How does a massive airplane stay locked at the same altitude for hours without the pilot touching the controls? It's not magic, it's one of the smartest systems in aviation, the autopilot. And it works harder than you think. When you glance out the window at 35,000 feet, the plane looks like it's gliding on invisible rails. But the truth is, the air is never calm. Tiny gusts, turbulence, temperature shifts, even passengers moving around try to push the plane off balance. Left alone, the aircraft would drift from its assigned altitude within seconds. Something has to fight back. That job belongs to autopilot. Altitude isn't just about comfort, it's about safety. At cruising levels, planes are separated by as little as 1,000 feet. A small mistake can put two jets on the same path. Altitude also controls efficiency. Climb too high and the engines struggle, drop too low and you burn extra fuel. And for passengers, even a small wobble can mean spilled coffee. Precision matters, and autopilot delivers it. To hold altitude, the system first has to know it. Barometric sensors measure air pressure, the key to altitude. Air data computers process this info constantly. Radar altimeters kick in near the ground, measuring the plane's exact height above terrain. These sensors never stop reporting. Without them, autopilot would be blind. All that data flows into the flight control computer, the brain. It compares the target altitude with the real altitude, thousands of times per second. If there's even a tiny difference, it calculates a correction. This is done using feedback loops and special algorithms called PID controllers. In plain English, they look at the error, predict where it's heading, and make a balanced correction. Not too weak, not too strong. Just enough to keep the plane locked in place. Once the brain decides, the hands go to work. Servos quietly move the elevators and trim tabs, adjusting the pitch of the aircraft. It's like nudging a seesaw. Tiny, constant moves keep the balance perfect. These corrections happen so smoothly you barely notice them in the cabin. When turbulence hits, the autopilot shines. Instead of jerking the controls, it makes rapid, gentle micro-adjustments. Hundreds of small corrections smooth out the bumps and return the plane to its assigned altitude. This balance is tricky. Correct too aggressively, and the plane would oscillate, up, down, too gently, and it would drift. Engineers tune the system carefully so it feels steady and natural. Autopilot isn't one size fits all, it has multiple modes. Altitude hold, stays locked where you set it. Vertical speed climbs or descends at a chosen rate. Flight level change manages pitch to keep a set airspeed. VNAV follows the programmed flight plan, changing altitude automatically. Each mode is like a different tool in the pilot's toolbox. Together, they make vertical control flexible and precise. Because altitude is critical, nothing relies on a single system. Modern jets have triple redundant computers, multiple sensors, and constant cross-checks. If one computer fails, another instantly takes over. If two sensors disagree, the system warns the pilots. It's layers of safety, all designed to make sure altitude is never lost. Even with all this automation, pilots aren't passengers. They monitor, cross-check with air traffic control, and take over if needed. Autopilot doesn't decide where to fly, it just makes holding altitude effortless. Think of it as the world's best co-pilot, precise, tireless, and always on duty. In the end, autopilot is what makes long-haul flying safe, efficient, and smooth. It's the invisible hand that holds an aircraft steady against a chaotic sky. What looks effortless is actually a non-stop battle of sensors, computers, and control surfaces, all tuned to perfection. So next time you're cruising above the clouds, remember this. Every second, autopilot is fighting turbulence, correcting drift, and keeping your plane exactly where it should be, at the perfect altitude.